Here's an equation we'd like to solve. Notice there's an x in it. When we're solving an equation, we often want to find out what x would have to be to make the statement true. Let's just explore whether or not x could be 2. Just made that number up randomly. If x were 2 and we simplified the equation, we would get a statement that's not true, and therefore x isn't 2. Could x be 6? Let's simplify and find out. Simplifying leads us to a true statement, thus concluding that x equals 6 is a solution to this equation. So far it seems like we're just guessing numbers, which is not the best strategy. A better strategy is to use algebra and do anything to both sides of the equation we want. For example, I could add 7 to both sides of this equation. But if I did, I'd get an equation that's not any simpler than the one I had before, so maybe adding 7 isn't a great idea. I call that valid and useless. Subtracting 1 would be more useful because it would make the equation simpler. Here, dividing both sides by 3 would isolate the x and give us the answer we're looking for. The goal here is to do whatever you want to both sides to make the equation simpler and ultimately get an answer. Here's another equation. Remember, we can do whatever we want to both sides of the equation. Could I subtract 1? Yes. Could I add 5? Yes. Could I subtract 4x? All of these are valid ideas. The goal, however, is to cancel something and make your equation simpler. To that end, adding 5 would be a good idea and cancel out the negative 5. Now next, I could add 21 to both sides and cancel out the 21, but that wouldn't give me a simpler equation. However, subtracting x from both sides would cancel out the x and give me a simpler equation. You can do anything you want to both sides. What I like to do is do whatever operations will get my x terms on the left and my constant terms on the right. But again, there's no single right way. At this point, dividing both sides by negative 21, totally valid, but it wouldn't get me a simpler equation. By contrast, dividing both sides by 3 would get the x by itself and thus simplify the problem. Here's another equation. Sometimes you have to simplify one side of an equation before you can begin the solving process. The right side is not simplifiable, but the left side is, so I'll use algebra to simplify and combine like terms. Now would be a good time to start solving the equation. Remember, our goal is to get x terms on one side and constant terms on the other. So I'm going to choose to subtract 7 from both sides. That will cancel out my positive 7 and get me one step closer to my goal. Another good choice here would be to add x to both sides. That would cancel out the negative x and get me an even simpler equation. Finally, dividing both sides by 4 will give me what x equals. Sometimes unusual things happen when solving. As you'll see in a few minutes, one of these equations has all possible numbers as its solution, and the other equation has no solution at all. These are rare, but worth looking out for. Either way, you go about the normal solving process. On the left, I would simplify the right side and then get rid of any x terms on the right. And what you'll notice here is that you've gotten rid of all the x terms. And we simply have 7 equals 7. There doesn't seem to be anything here to solve. If we look at the other equation, we could simplify the right side as well, and also subtract 19 from both sides, which gets me down to here. And then subtracting 2x from both sides gives me this. One thing you'll notice here is in the solving process, in both cases, we have completely lost the variable altogether. When this happens, one of two things is possible. You're going to have all numbers as your solution, meaning literally any value of x will be a solution to this problem if you get what's called an identity. 7 always equals 7. That's always a true statement, and therefore x can be any number. On the other side, you'll get no solution occasionally. That, you can tell, will be the case whenever you get a statement that can never be true. Negative 12 doesn't equal 0, and therefore there is no number that x could possibly be. Watch out for these unusual cases.